All right, so this is demoivres theorem. And so all it really is multiplication to the nth power. So we're going to do z times z times z times z times z times z times z n times, and we get this. So all it is the multiplication property that we were using before, just n times. So you can think of it this way. We have our z1 is r cis theta. So z1 times z1, that's our z squared, right? Would be this, which gives us this, which is this. So you can see there's already the 2 and 2. So let's try it again. So now we're going to multiply the z squared by another z, right? And so we end up with r cis theta times r squared cis 2 theta. So using our rule, we get r times r squared is r cubed. And then theta plus 2 theta would give us this. So z cubed is this. And so it's going to be that same pattern. If we do another z1 onto it, we're just going to put another r and another theta. And so z to the n would just be this. Okay, so that's our formula. So it's a very nice one that works really well. So to do this, all we have to do then is cube the radius and multiply the angle inside, just like that. So all we're doing is multiplying and using the power. So this would give us 27 cis 90 degrees. And there you go. That's demoivres theorem. All right, let's try another. So this one we're going to rewrite. So this would become cis 45 degrees to the power of 8. And so you notice there's no radius on this one. So the radius is just 1. So this would just become cis 8 times 45 degrees. So 8 times 45 is 360. And so we can leave it at 360, or you can subtract 360 and make it 0. But this would be cis of 0 degrees. And there you go. So where it benefits is you would actually have to do rad 2 over 2 plus I rad 2 over 2 to the power of 8. And so think about that, multiplying this 8 times, right? You can even use binomial expansion, but it's still painful. But what do you get? 1 plus I to the 0, because it's from here. So cosine of 0 is 1, and sine of 0 is 0. So you get 1. This is 1. All right, so here's how we can use it. So the first thing we're going to do is take our 1 minus I rad 3. So we know we are over here. This is a positive 1 and a negative rad 3. So we know we're in quadrant 4. So we need to make sure we stay there. All right, and then we rewrite it. So our z here is 1 minus I rad 3. So that would become 1 comma negative rad 3. So we're going to put it in polar form first. So r squared equals 1 squared plus rad 3 squared. And so r is the square root of 1 plus 3, which is 4. So it's 2. And then theta equals inverse tangent of negative rad 3 over 1. And we plug that in our calculator, but we already know what it is. Second inverse tangent of negative radical 3. I'm not going to put the 1 on the bottom. Hit enter, and it says negative 60 degrees. But again, I want to keep this in the positive area. So negative 60 plus 360 is 300. Because I want to make sure that we stay in quadrant 4. So we know that our new point is 2 cis 300. And so that's our radius of 2 and our angle of 300. So we know we are in the correct location here, right there. Everything is good. And so we can even check it in Desmos. So I put my real part as 1. My imaginary is negative radical 3. And you can see we have an angle of 300 with a radius of 2. So everything checks. We're in the correct location with the correct angle, correct radius. Everything's good. That's very important. And so now we just replace it. So we take our 1 minus I rad 3 to the 5th, and we replace it with its polar form to the 5th. And so this becomes 2 to the 5th, cis 5 times 300. And so 5 times 300 is 1500, and 2 to the 5th is 32. And now we just need to convert it back. So 1500, and remember, just keep subtracting. 360, hit enter, minus 360, hit enter. Could have done this a lot quicker, huh, if we just multiplied it by 360 times 4. But we get 60 degrees, so it's 32 cis 60 degrees. And so now we can convert it back. So that is our polar form, but it would be 32 cosine of 60 plus I sine of 60. So this is 32 times a half plus I rad 3 over 2. And so that would be 16 plus 16 rad 3 with an I. And that is our complex form. So what we just did was took 1 minus I rad 3 to the power of 5, multiplied it out to give us this. And so you can see on Wolfram Alpha it did the same thing. Gave us the same radius, same angle, same answer, same location. All right, so let's do it one more time, but this time you're going to try it. So you're going to recreate the steps I did up here, convert it into a polar form, and then use demoivres theorem, and then convert it back to rectangular form. And then I want you to go on Wolfram Alpha, plug it in, and verify your answer. Okay, hit pause now and try that. Okay, so you should have 2 cis 330 degrees. And so using demoivres theorem, we get this, and then taking the 1980 back, we get 180. Plugging it in, you get negative 64. So you could multiply rad 3 minus I to the power of 6 out, and it would take you forever. Or you could just do this and use demoivres theorem. And then checking it in Wolfram Alpha, you can see there it is. We get negative 64, and it was 64 cis 180, which gives us here. Everything checks. So that's demoivres theorem. It's very nice, isn't it? It's beautiful.